Hello, does your life seem empty and lacking direction? You have no friends and no money? You need to take this course on how to program a monkey. If you are not completely satisfied, then you are stupid.
Hello, so thanks for the intro from the monkey. Right, so the objectives of this video. One, code a monkey with a flashing eye. As you can see in the inset, we already have that. That was done using a Arduino example blink code, which you may or may not be familiar with. Now, for those Python fans out there, just hang in there because this will all make sense later on. So the next step will be to code the Arduino using native C code and not using the Arduino GUI with the void setup and the void loop. You'll see what I mean shortly. After that, we'll look at how we can automate this using Python. Well, I say Python, Jupyter Notebook, which uses Python. Also, we'll look at using compiled code to make your Python scripts faster. So there's quite a bit of C, Python overlap going on here. If you don't want to touch C, it looks difficult or you're not interested, still worth knowing these things because under the bonnet, it actually does have some relevance with Python. So yeah, I would say it's worth watching, but you know, I'm just a YouTuber who's after clickbait, and to be honest, I think I'm probably the only person who doesn't do thumbnails going, I really, really dislike those. If you make YouTube videos and you do this, then stop watching now because we will not get on. I really do not like those. Anyway, rant over. Let's begin. So the first thing we're going to do, well, we've already coded a monkey with a flashing eye, but what we want to do is, let me just get this out of the way, and let's look at the traditional way of blinking. I should have just gone here, shouldn't I? The traditional way of blinking an LED using an Arduino. So I'm just showing this in Notepad, but this is what you would have in the graphical user interface with Arduino. So your void setup, so that runs once. Initialize the digital pin 13 as an output. So the benefit of the Arduino is that it's got analog and digital pins. So you specify that pin mode for 13, it's an output. So that pin only gives outputs, it doesn't take inputs. Then the loop function runs over and over again forever. So it's an endless while loop, and all it's doing is setting the output to pin 13 to high. It waits for a second. You can read the comments. Anyway, that's how you normally would do it, and that's what's currently running on the Arduino right now. As you can see, hopefully you can see the monkey with the sunglasses with the flashing right eye. Don't ask me why I did that. I don't even think I know why I did that, so there we go. So I found this article, Timo Denk's blog. Thanks, credit to Timo for all this, really. I'm just going to wing it, really, so let's see how we get on. This is live coding. So, Atmel Studio. In order to follow, you need a Windows machine and a microcontroller programmer. No, we don't. No, we don't. We'll use Linux and we'll use Vim. So, yeah, I think I've already got everything set up to, so I think these are the two bits that I will need to delay.h. Right, so in a moment, my code is a slight modification on the blink code because it's blinking for 100 milliseconds and then it's staying off for 1,000 milliseconds. I believe this is using the same delay. You can see this set a constant. Oh yeah, constant there at the top, define. Right, let's right. rather than read the instructions and everything, let's just do it, and once we've broken it or it doesn't work, then we'll come back. So that's the original code that we just looked at in Vim. D, Shift G, deletes that. I to insert, Control Shift V. There we go. So I do slightly know what this is doing. So we're using bitwise operators here, which is on, if we just go up a bit. So while one means while true, there we go. DDRB, digital something. So basically that is the binary for pin 13, I think. Don't quote me on that. That's a bitwise OR. And then just got port B, and that's okay. So it's doing an OR there, and then it's doing a, God, I don't know. Is that an AND? Let's just run it anyway. Right, let's get on with it. Compile. Wow, it's compiled. What we'll do is we'll get it working, and then we'll go back and look at the theory. I think that's how I like to learn, really. So let's upload it, what we just compiled, and we should notice if it works, the blinking should go from a long dark with a short bright to 1 second bright, 1 second dark. And that's worked. So I know all we've done is gone onto a web page and we've copied some code, but we've already gone in through the hard work of setting all this up to compile and upload from the command line, identifying the correct port. Right, anyway, I'm not going to blow my own trumpet just yet because that's not overly amazing. So now we know we've got this working, one thing we could do, which Maxim, if you ever watch this, hopefully you do soon, blinking assembly, I'm going to get to that shortly, or I'm going to attempt to. But let's just read this for a second. And the well-known Arduino blink sketch implementation in plain C. So that's what the objective here was. Code in Arduino using native C code with no GUI. So note that functions like digital write or delay do not exist. Port manipulation and external header files need to be used instead. So avr/io.h, that's installed when you install Arduino-CLI. So if you saw my earlier video, I did sudo apt get install, I think was it Arduino-CLI, can't remember. Include util/delay.h. So again, that's another additional C library. I don't think that's not a standard C library, is it? No. Anyway, int main void. Let's here we go. After selecting your device, the following two snippets. The fifth, so D13 is the 5th pin in the port B register. Yeah, so we've got 0. We go from right to left, so that's 0. That's 1. That's 2. That's 3. That's 4. That's 5. So we're telling it you go from right to left, and it's the 5th one in. Well, it's number 5. The microcontroller's clock frequency here is 16 megahertz. Needs to be defined as well. Okay, so if we didn't do that, then it wouldn't be able to calculate milliseconds. Is there a summary at the end here? In order to write your own more complex C or assembly programs, you're going to need your microcontroller's datasheet in hand. So this Arduino is an 80 mega. What's the Arduino Uno? It's the Arduino Uno mega chip data sheet. So it's the Rev 3. It's taking us back to the Arduino store. Just wondering if there is actually a data sheet. Why does it matter? And at it 2560. Yeah, I thought mine was 256. So in a second we'll get past this theory, and then we'll go back and then we'll look at how to automate this, and then we'll get to the new bit. If you're not interested in Arduino, we'll get to the bit where you can actually use C code to speed up your Python programs. I just thought I'd use this monkey. In all seriousness, I thought I'd use this monkey. Just everyone looks at an Arduino and they sees the light flash. Is a bit boring, so hopefully you'll remember this a bit more in a good way. 435 pages. Wow. I just was hoping to see a diagram. So even in the datasheet, they've got assembly code instructions. Okay, so without going down the assembly rabbit hole, let's look at how we can automate or simplify how to update the code. So I'm logged into the Raspberry Pi. I've now got my link, which I'm going to copy out of here and paste up in my desktop or my laptop, and that's not what we wanted at all. I don't want to do all that. So you get this link with the name of your machine, and then you just actually have to just edit it and put in your IP address. Sure, if you'd done this once, you'll know off by heart by now. Okay, so now we're back on the. If you watched the previous video, you might recognize this file that we're about to load. Yeah, so what I did at the end of the last video was this. So let's call it a sensible name. We'll call it PyArd automate. Not totally automating it, but you know, kind of. So what I was thinking was to actually let's open a new tab on here. I need to log back into the Umbrel, the Raspberry Pi. And let's get rid of that. And then let's insert back in the code which we had from the example, which was the native C code. Actually, in fact, let's not do that. What I'll do instead is try and edit that file from here. So what we'll do, if you're on Windows, some of this may not make sense, but to be honest, the whole kind of point here is, or was on the previous video, was to edit, compile and upload from a Raspberry Pi, which was, you know, you can cable tie it to a metal beam in a factory somewhere, and then you can remotely flash your Arduino or microcontroller. Just because I keep saying Arduino, this applies to any microcontroller concept. Okay, so first thing we want to do is cd to other blink Arduino compile blink compile. That's actually let's just copy that line, add a new line. So I'm just going to run this one, check we're in the right directory. Yeah, so then you want to, so that's just listing the directories. Then we want to change directory into the one called other, folder called blink2. And then what we want to do is get rid of all this. Wow, it's running really slow. And then double ampersand. And right, what I need to do here is add another line. No, what I'm going to do is create a string in Python. C underscore code equals then 3 pairs of quotes and paste in all of the code. So I'm hoping this will work, and it should do because it's all contained within the string. And paste that in there. So that is what you would call your Arduino sketch. And I'm just going to execute that cell just to check it. Yeah, it's fine. And then, so this is a mixture of C code, bash on the Linux command line, and in fact, do we even need to use Python? Kind of. In fact, we could just write this to so we could do cut this is where I'm mixing Python and Bash. I don't think this will work. So what I need to do is write the C code to a text file using Python, and then cat the text file using Bash. So just bear with. This might seem a really complicated way of doing it, but it's just an example of how you can automate it, and hopefully just show you how you can link Bash, Python, C. It's probably highly unprofessional, but I just want to kind of show you just how to experiment with stuff. Right, so what we want to do is Python with don't know why that's with open. What should we call it? Link to src.txt for write as Arduino file. af.write, and then we're going to put all of C code inside it. Let's just run, so run that and run that, and there's no errors. So if we just add in another line there, which we'll just do a mind the right directory. Yeah, so now if I run that, we should see the blink2_src. Yeah, there we go. So then what we want to do is then cat, so if I copy that, then we just want to cat that to that's right. So then we want to cat that to blink2. To blink2.ino. Let's see if that works. Right, run them in sequence. So that gets the variable, that writes the variable to the text file, that just does a list, that cats it, no such file or cat blink to perhaps we need a path in there. Let's try again. So the variable, write the text file, list it, we know it's there. Okay, no such file or directory. What am I doing wrong here? What I could do is actually just do it on the Raspberry Pi. So what's going on? So what am I? Let's just see what we're listing. We got directories wrong here somewhere, so let's just go back up. It's put blink src.txt here, whereas what we need it to do is put it into here. So let's just change that. So let's go. If I was doing this properly, I'd put in the, I'd turn the path names into variables and so on. But this is just a quick and dirty proof of concept, really. So what we're doing here is let's got the variable. Let's write the code. Home umbral other is a direct. Blink 2 underscore SRE SR. Right, now let's try again. It's actually harder doing this because the writing's so big, just so you can see it. Right, so it's built. I'm not even doing the ls in the right directory. Let's get rid of that line. Right, let's just try this now. So cd to other blink 2. So let's try that. No. So what we want to do is we want to cd to and then I'll get rid of that. I think get rid of that. Right, run again. There we go. So now it's used cat to output the text file to create a new blink2.ini file. So if we do ls minus latr, you can see 1 minute ago it made a new .ini file from the srt.txt file. Good, so finally we got there. Sorry about the gross incompetence. So what I've done is, let's add some notes here. So markdown. Enter the sketch as a Python string. And then what we did was write the sketch as a variable to a text file. And then using bash, to be honest, we could just I could just write that text file. I could just write that text file as a .ini file and miss out that step, but it's good practice. You just see now to be honest, if you wanted to add more stuff or edit that srt.txt file, it gives you the option. Using bash, write the text to an Arduino file extension. So really that Arduino INO file is really just a text, it's a text file. So then we've written it as a text file. So really all we need to do now is that same line as before where we just compile it and then we upload it. So before we do that, just so that we can see if it worked or not, instead of blink delay 5000 milliseconds, what I'm going to do is do blink delay on and blink delay, let's do Let's call it on. And there we will just assign that one to turn it on. So on, because then you can have different on and off timings. So let's make that one 200 on. We'll make that 1,000 milliseconds off. Good. Right. So the whole point of this is kind of the crux of this video, really. It's just other than what we're about to get onto next. This is showing you how you can have an Arduino sketch as a Python string. And obviously, you can generate this string with Python code. So that could be a variable, that could be a variable, and then you build it up into a string, and then you eventually, once you've got your string, you then set it to your variable C code, which is what you then write out to the file. So what we're really showing here is you could construct an Arduino sketch from a text file using Python strings. Right, so with all that being said, let's now run that, run that, run that, run that. And if you keep an eye on the monkey's eye, let's just run that file, which has just made the INO file. And now, if we flash it, there we go, it's worked. So you can see the monkey's eye is now flashing for 200 milliseconds and is off for 1 second. On for 200 milliseconds, off for 1 second. And to show, now we've kind of automated this, let's just go and change. Let's make it blink really quickly. So 100. I can't make it too fast, or you won't see it on the camera. So let's go for 150 on, 150 off. So let's just do run all cells. And keep your eye on the monkey's eye. There you go. That's every 150 milliseconds on, 150 milliseconds off. That monkey is really, I think the monkey's probably, I think he's taken some substances he shouldn't have done. Or he's got some kind of nervous disorder where he blinks, he can't stop blinking. So hopefully that's shown you how you could create an Arduino sketch using Python. I don't want to teach you to suck eggs, but you can make a string, you can put your own variable, create loads of variables, modify them, and then you can put them into one big string. Once you've got the string, then you can create a text file, and then with that text file, you can then, let's just change that to Markdown. And let's just add in another comment there. I'll probably put this up on GitHub if you want. It's not really pioneering, but it's kind of creative with code, should we say. Creative way to automate generating and uploading to an Arduino. Personally, this is good because it allows you to just modify the variables as you wish without having to worry about all the defining the constants and all that stuff. And if it's here, you've always got it. So so what was I going to say here? Oh yeah, compile and upload. And the whole point of this is you can automate it. It's not, you're not reliant on a GUI, so you don't have to be at the machine to do it. You can do this on a remote machine, i.e. this, the Raspberry Pi could be, well, it depends how far your Wi-Fi will go, really. You could have a repeater. So as long as you've got Wi-Fi in your factory, or even LAN in your factory to a wireless repeater, and then this could be up on a metal beam 30 feet high, or say 10 meters high, just with a USB lead going into the Arduino here, and then this is connected to the machine. So instead of a monkey, imagine this is a you know, a big machine making something, stamping out tin cans or sawing up bits of wood for posh people's kitchens who yeah, anyway, so that's that. Next, let's go back to the agenda and how to use compiled code to make your Python scripts faster. No, I'm just going to leave the monkey in the background, but what should I do? No, monkey's got to go, I'm afraid. So say goodbye to the monkey. And I'll be back in a second and we'll carry on with making scripts faster using compiled C code. Okay, so C types examples using shared object libraries with Python. So yeah, this will be part Python code, part C code. Even if you don't want to ever write C code, just know that this exists because you will at least be aware that there are faster ways of running code than Python, which you might have known already, but we'll actually prove it here. So I wrote this yesterday. I've probably forgotten bits of it already. Let's just keep it very neat and tidy. So I'm not going to clone it and do all the fancy GitHub stuff. Let's just actually what I will do is I will just show you. So this is the structure. So we've got a Python file in the top directory, and then we've got some source C code here, and then we've got a .so file which was made from that C code, and I've just called it tractor just because it's a really random word. I've got so many files called demo and demo1 is untrue. So what we need to do is start a new project and yeah, let's do save as. C types YT, and this will be the C. This will be so we need to let's make a new directory inside here, which will be the tractor one, which contains the C code. And then we want a file which we will then call basic function.c. And then we will do open folder. I know this seems like a lot of hard work just for a little example, but the structure is important here. So this is why I'm doing it. I just want to show the structure is really important. That is right. So if you don't know C, basically what I'm going to show here is a very simple function which uses a standard library. The H is a header file, and that is if you've got Linux, Windows, Mac, you'll have these by default already installed with your operating system. Void is just a function that doesn't return anything, and unlike Python, with C you can move stuff around in memory, so you don't have to return. And then returns a square of an array. So you have an array of, which is basically in Python it's a list. So you pass the list, and all it's doing is it's taking the first number in the list and it's multiplying it by itself, and that's array out. An array out has a pointer, so it's actually putting it back in the memory. So you don't need to, as I say, because it's a void, you don't need to return anything. This is the syntax to compile. I'll show you in a second. But this is the syntax to compile a C file into a .so file, which is a shared object, which is what the Python code will then access. So only 3 files, so hang in there. This is basic function.c. Paste that in. The 2 forward slashes is a comment in C. So there we go. Next, so the other file, we won't paste in the SO file because we're going to generate that. So go back up one directory, and then we just want to, this is the Python code which calls the C code. So I'll just copy and paste this in for now, and then we will go through it once I've demonstrated it working. So Python helper function.py. Is that what it's called? A basic function helper.py. So that goes in the top directory. So let's just now we've named the file. I just do that to name the file. I type it into the top of the text file, then save a text file. Right. So what we've got is, so far we've got a C function. So you could do hello world here, for instance. It would actually be a lot easier to learn if you wanted to do that. I've just put in, sometimes it's difficult to go up once you've done a hello world, it's difficult. The next step up seems really huge. So if you can, without worrying about the syntax of C, as long as you can understand that it's doing a loop for I, and all it's doing is it's multiplying, in Python language, if you're multiplying the list item I by list item I by itself, and then you're updating the list item at that same index. Right, so next, the function helper. So what we're doing is, again, I've not written this from scratch. Slight, what's the word? Admission? Yeah. So we're using Ctypes, and if I hover over that, so that's Ctypes is a Python wrapper to run C code. I've included time it because we're going to do some timings later on. We're not going to run this just yet because we need to compile the basic function into the shared object. So we'll come back to this in a second. So let's get on with it, and we will open up terminal, and then we'll do GCC so hopefully you can see that GCC is the C compiler. So unlike Python, which is interpreted and it's runs at runtime, or it's run by the interpreter, what you have here is -o for output, and that's the name of the output file. We need to make the .so file. Dash shared dash lowercase f pic dash o2. So there's 3 things here really that to really focus on. These switches, just copy these if you're just doing this for the first time. So really, GCC, the name of the output file, which is a .so because it's a shared object, which is what you need for Python, and then basic function.c, which is the C file. So the C file is what we've got here. The .so file is what we're about to make, and then that is what Python will use. So hopefully this will compile. And basic function.c. Because I'm not in the tractor directory, so cd tractor. Now run it. So when you compile in, obviously the paths are very important. So let's run again. And no errors. So, and if you see up here now, sorry, my head's in the way, isn't it? Let's just move that across. Now you can see we've got basic function linux_linux.so that was created from bash_function.c. In fact, let me change the color here. I think for doing, is that better? Yeah. So what have we got? We've got C code, which I'll close. We've got the SO. So the SO, basic_function_linux. And we call that based on the platform name. So we imported sys, and sys.platform will detect it we're running Linux, and then that puts Linux in here. So that will then say libpath equals tractor directory basic function underscore linux.so, which is exactly what we've got here. So then we do try basic function. This is a variable that we are setting to an instance of class, and you have to pass it lib_path. So you have to pass it the shared object. Here, what we're saying is, so this value here, then we then use it here, but then we do .c_square. Why are we doing .c_square? That is the name of our function, which we wrote in C. So we wrote it in this file, we compiled it to an SO file, and then we're calling the SO file from Python. So it's kind of a three-step process. Then what we're going to do here is write a Python function which is called doSquare using C. We're passing in a list. We look for the length of that list. With C, you need to know the length of an array. Python obviously does all that for you, but with C, you need to know the length. And then we're creating a pointer, which is a type double. A C-type array of double of size n, basically the length. So we're getting the length of the list that we're passing to it. And it can be used by the C function, initialized with the values of list in. So that's the length of the array, and then we're passing it the values, and that star there is because a list is an array, which is an array in C is actually a pointer. Right. I'm going to pause that there, and then we're going to run it. So we'll run it, and then we'll look at the different times that it takes. Okay, so let's get on and run this code. So let's just see if it works. Should do. Yeah. Right, good. What have we got? 936. Where did that come from? That's what we're passing to the function. So the Python function called doSquare using. There we go. So the function, we declare it here on line 29. We pass it a list, and then when we actually run it, this is inside an F string, so we just doing it on the fly and then printing it. So we're doing do square using, and then just a list with 2 values. So if we want to run it again, we could put what's the square root of 12? That's 144, isn't it? We could do 10, that would be 100. So we should get 9, 36, 144, and 100. Let's run it. There we go. And the important bit of this video, just to kind of demonstrate to you, even if you don't want to run this yourself, even if you don't want to write this or copy this yourself, just run it once more. That's where the rod. Let's run it again. Okay, so I've used time it, and there you can see that it's taken why is it doing it in different formats on here than what it was doing when I was doing it before? Don't know. Let's just see. Here we go. So the time difference in C I'm doing less numbers with that has me confused. Why was the Python running quicker? So 12 and 10. No wonder it was running quicker. It was only doing half as much work. Right, so I've just written a little function here which actually just iterates through each of those values and squares them. There's probably a more elegant way of doing that, or even a list comprehension, probably be quicker, but just for demonstration purposes, just want to show the difference between doing that function in Python and running the do square using, oh yeah, we just need to do that as well. So 12 and 10. Right, there we see the time difference. So running it as a C program takes 4 times 10 to the minus 5. Python takes 6 times 10 to the minus 5. Let's run it again. So 1.7 times 10 to the minus 5, 9 times 10 to the minus 5. So, and as you can see, if we had another number in there, in actual fact, that's just printing it, so we don't need to worry about that one. This is the actual function that's running and we're doing the timer on. So let's put in a big number to square. That should make the difference even more. So that was for the C version, and then we do it on the Python version. And let's see the time differences. There we go. So almost double the time to execute running it. I know you think I'm cheating because I didn't put it in there. That should not make any difference. That's just what it's printing out to the screen. So run it again. Wow. So C is taking 2 times 10 to the minus 5, and that's taking 9 times 10 to the minus. So it's over 4 times as much time using Python code. Oh, there's 50% more. Run it again. Yeah, nearly double. That was really quick. So yeah, 1.00120026. Yeah, that's 2.6 times 10 to the minus 5. Let's run it again. So 9 times 10 to the minus 6, that's 6 decimal places. There we go, 1.6, 2.5, so almost twice as long. It varies obviously depending on CPU cycles and all that kind of stuff, but in general, I know I've not written the Python function in probably the optimal way, but I just wanted to demonstrate that, yeah, it's one of the reasons why using NumPy is such a good idea, because it's faster than trying to do the equivalent within Python, making your own functions. NumPy is compiled in C, so all that's going to run so much faster. So yeah, if you hopefully I'd say if you I'll put this link in because this is where I've kind of plagiarized part of this code, so credit to them. Reptate, REPTAT. Follow the link, I'll just show you. The internet's a bit slow here. Interfacing Python code and interfacing Python and C code. So most of what I've done is covered here. If you are on Windows or Mac, then these are the instructions to compile your basic function into your shared object. Can you see that? I'll zoom in a bit more. Yeah, so basic function is where you write, that could be hello world if you only want to do hello world. Again, GCC if you're on Windows, Mac or Linux. You compile it as C. C is kind of platform agnostic, should we say. They were calling their directory theories, but I'd called mine tractor just to be different. So as you saw, I started with a C function, wrote the C function, compiled it into a shared object. If I go and look at the shared object, file's not displayed in the editor because it's either a binary, well, it is a binary, so that's why it's not displaying. The Python code, I'm not going to talk all the way through because kind of unless you write it from scratch, it's not really going to serve any purpose. Plus, I would not be able to write all this from scratch. I've copied it and modified it, let's just say, but I know what every part of it does. It's just I wouldn't be able to write it from scratch off the top of my head without referring to notes and lots of dodgy typing. So yeah, that's my caveat. So yeah, if you want the code, then Reptate, read the docs. I'll put that in the link in the description. And yeah, I know this has kind of been covered a lot of things. We've covered automating the creation of Arduino files, editing Arduino files in native C, using C to speed up Python by compiling some Python code as a shared object and then calling it from Python. And yeah, as you saw, 1.2 against 3.4. So yeah, Python, not the fastest. If you want to speed up your Python code, is there anything that you could simply compile it into C and call from Python? Yeah. So I'm not advocating copying this code, but this really is just my example, which is on RGGH GitHub. If you want to look at it, it's on here. And really, just remember that it's 3 files. It's the C file, which you put inside here. You compile it into a shared object, then you call it from Python. So really, you only write 2 files. You write the C code file and then the Python file. Hopefully this has been interesting or given you food for thought. And yeah, let me know if you like the video. If not, then sorry, but well, that's life, isn't it? Don't forget to subscribe and yeah, you know all that chin rubbing and all that that they say on YouTube and all that stuff. Yeah, so thanks for watching.